Hey folks, the purpose of this video is reviewing some sections from Chapter 13. Okay, the first section is our reciprocals, that's secant, cosecant, cotangent. Second section, simplifying those trig identities, so that's like those expressions that we want to get down to a single term. And then 13.4, sum and difference of angles and the double angles, that was split into 2 days. And then half angles, those really ugly formulas that sometimes are a little bit tricky to simplify. So here's how this is going to work. I'm going to show you a problem, and then you are going to pause the video and attempt that problem. Okay? When you're done, you can play the video and I'll walk you through the answers and how I got it. Okay, make sure you have your note card handy before you start this so that you're able to use those formulas as you go here. Okay, let's go ahead and get started. All right, first problem here, we're dealing with finding the value of an expression. You're given cosecant and a specific quadrant, and you're asked to find cotangent. So this deals with those reciprocals. Okay, pause the video, get this done. Here is the answer. This quadrant specifically was quadrant 2, and we know that the missing side that we have to go find here using Pythagorean theorem is going to be negative as it goes to the left. Okay, remember we're taking the hypotenuse squared minus that squared. Always be sure to check whether that will simplify. In this case it doesn't, but a lot of times it does. So always double check the sign and that you're simplifying. Okay? From there, we're asked to find cotangent. Okay? So with our triangle, the original was the hypotenuse over opposite, since cosecant is the reciprocal of sine. Okay? With cotangent, that's the reciprocal of tangent. Since tangent is opposite over adjacent, that makes cotangent adjacent over opposite. I highly recommend that you use opposite adjacent hypotenuse to do these for you. Okay, you just have to use your note card to tell you what reciprocal goes with the original trig function that you already know. Okay, let's go ahead and try another one like that. So again, label your triangle in the correct quadrant and then solve for that missing side. So this time you can solve for secant. Pause the video and get that done. This one was in quadrant 1. Again, we're taking hypotenuse squared is 9 minus 1 squared is 1 to get 8, and then we can break that down. This is an example of where the radical that we have simplifies. You don't want to leave that the square root of 8. Okay? Another thing we have to check for is sign. Since we're in quadrant 1, everything is positive. Okay? So now we're supposed to find secant. Secant is the reciprocal of cosine. Since cosine is adjacent over hypotenuse, we flip that over for secant. And then because that looks like 3 over 2 radical 2, we have to rationalize by multiplying by that radical 2 over radical 2 on the bottom. And so that's where this 4 comes from. It's 2 times the square root of 4, which is just 2 times 2. And then on the top, you just smush them. All right, let's look at another. This one is from 13-2. Okay, so we're going to do a few more of these ones in the last section because it's something that we struggle with a little bit more. Okay, so pause the video and try to simplify this. Remember, it's not done until you have a single term remaining. Okay, no fractions allowed, no plus or minus, no multiplication, one term. Here we go. Cosecant is 1 over sine. Tangent we can call sine over cosine. Those sines cancel with multiplication. So we have 1 over cosine, which is the definition of secant. Okay, so hopefully that one wasn't too bad for you. A lot of times when it's a product, they don't get too messy. So let's look at another one. Here we've got a quotient, we're dividing, so a lot of times when that happens we have a fraction within a fraction. So I want you to try this and see if you can organize the fraction within a fraction or eliminate it. Pause the video and take care of this one. Now I said take care of the fraction within a fraction, because the way I would do this is multiplying by the reciprocal to start out with. So instead of dividing by tangent squared, I can multiply by the reciprocal squared, while the reciprocal is cotangent squared. It's absolutely okay if you wrote this as sine over and then called tangent squared sine squared over cosine squared. Okay, but what's really important is that you keep those grouping symbols there, or you make this really dark and bold or long so that you can keep track of the original fraction, because that creates a fraction within a fraction. And you have to be careful when you simplify those. Okay, you can't just cancel that out, because this cosine, we have to figure out where it lands when you're done. Okay, so we really are multiplying by the reciprocal. That's what this step shows. Essentially, we're actually doing this on top and bottom, and that's how they end up canceling, because by writing this cosine squared over sine squared on top and bottom, we're multiplying by a very messy 1, which doesn't change the value. And then these cancel, leaving just that sine squared multiplied by the reciprocal. Okay, so if you didn't do that step, but you did this one instead, awesome. We're at the same step here where the sines cancel, and we're left with cosine squared. The next one here, we've got some squareds going on, we've got subtraction, and we've got division. So this one's a little bit more messy in the way it looks. Pause the video and try it out. Hopefully you recognize that the numerator was a difference of squares. Anytime you have a difference of squares or a sum of squares, you want to look at your Pythagorean identities. This right here is a Pythagorean identity right from your note card, and it simplifies to 1. The same thing goes for the denominator. It's another Pythagorean identity. Now remember, you sometimes have to move those identities around to make them look the way they do here, but it comes out to the same thing. Let me go ahead and pull up the note card so I can show you what I mean here. I'll just clip it. So on the note card, it doesn't say 1 minus cosine squared, but that first one has cosine squared and 1 in it. If we subtract over this cosine on both sides, we're left with sine squared is equal to 1 minus cosine squared, and that's what allows us to substitute for the bottom. Very similarly on this one, right here has cotangent and cosecant. It's not written in the same way it is here, but we can move some stuff around so that it is. Just by subtracting over that cotangent squared, we see exactly what we're given. Now do be careful, because just because it looks like a Pythagorean doesn't mean it always is. Sometimes it's the opposite. So this would be a -1 or a negative sine squared, and sometimes it's not 1 at all because it involves the wrong two things or the signs are flip-flopped. Okay, so be careful on those, but always look for Pythagoreans when you have that sum or difference of squares. But then once we have this 1 over sine, we can call it cosecant squared since that's the reciprocal. Next up, we're going to do some sum and difference or half angle problems. Okay, the instructions on the test are just going to say find the exact value, which means you get to do it however you want. You can draw a triangle if it's one you know. You can use a sum or difference if it's one easily done that way. Or if you're stuck, you have to use the half angle. So first up, we've got sine of 75. So the first thing you want to think, is this a triangle I already know? So the triangles we already know are multiples of 45 and multiples of 30. So 30, 60, 90, 120, 150, all the way around the circle, those are triangles you can know. Once it goes past 360, I don't expect you to recognize those, but all the ones before, be looking out for those. Then the multiples of 45 as well will show up, and then we have to also pay attention for things like 75 that really don't fall into either of those categories. That's when we have to either use a sum or difference or the half angle. Okay, so here's my little key to you, is if you see something that ends in 5, most likely, if it's not a triangle you know, you're going to use a sum or difference. And the easiest way to do this is let 45 be alpha and let beta be what it is left, okay? Whatever gets you to what you need. Because if it ends in 5, 45, what's nice about it is we know what the sine of 45 is. We know what cosine 45 is. It's a positive radical 2 over 2 every single time. So it saves you from having to type in at least one of those. Okay, so pause the video, use your sum or difference formula, and get this one done. All right, like I said, I'm going to use 45 for alpha, but you don't have to. What you do have to have in the end is a positive radical 6 and a positive radical 2 in the numerator of your fraction. That's it. Your work can look different from mine as long as your final answer is both positive there. Okay, so pay attention to signs. This one's lucky. Everything's positive from quadrant 1, so it ends up positive. Okay, remember you can check these ones by typing in sine 75 and typing in this expression and making sure they match. Next up here, sine 285. Pause the video and try this one out. Again, I'll always use 45. Now, one thing here, we've got 45 and 240. Okay, so if you don't know what the cosine of 240 is or the sine of 240 is, you can draw it. 240 falls here, and 240 is 60 over 180. That means 1, 2, square root of 3 looks like this. We've got left and down, so they're both negative, and then cosine would be negative 1/2, and sine would be negative radical 3 over 2. Or type it in your calculator. As long as your mode is in degrees, hopefully you should recognize off the bat, negative 1/2 is negative 0.5, and then we've been practicing that square root of 3 over 2. It looks like the decimal 0.866. Okay? Again, you can check it by taking sine 285 in your calculator and comparing it to this guy right here. All right. Next up is sine of 22.5. This one right here with the 0.5 is a very obvious clue that this has to be a half angle. Anytime you see 0.5 or 1/2 of a degree, it has to be done using the half angle formula. Okay, so if you see a half, use a half. Okay. Unfortunately, that makes our life a little bit more difficult. We'll do a couple of these so we can remember here. But when you recognize this as the half angle, make yourself a note of that. That's our half angle, so we need to know what's the whole angle. All we have to do is double this one, so that makes it 45 degrees. Hopefully you remember that we have to think about two things that are important for half angles. One of them is sine. We're given the half angle, so we know the quadrant is 1 because of 22.5 is in the first quadrant. And then we also need to know whatever cosine is, because in our half angle formulas, cosine is important. Okay, put that information together and try this one out. All right, that cosine 45 is radical 2 over 2. In quadrant 1, sine is positive, so we're going to use that positive out front. Okay, then we say 1/2 on the outside, and then just 1 minus cosine. Our cosine of our angle is that radical 2 over 2. Remember, always simplify this inside first. Okay, so what I did here is I replaced this 1 with a 2 over 2 to get a like term. So then this 1/2 stays in the next step, but then I can smush that together and call it 2 minus radical 2 over 2. From there, I'm just going to multiply straight across. This 1 distributes, but that just stays the same, 2 minus radical 2. And 2 times 2 is 4. But when you have this, I'll go ahead and rewrite it so we can see it very clearly. When you have this, it's really the square root of the top, which you see over here, over the square root of the bottom. Luckily for us in this case, 4 is a perfect square, which means it'll simplify to 2. With these half angles that are 0.5s, they're always going to come out nicely on the bottom there, so you won't have to worry about rationalizing in these cases. Again, you can check your answer by typing this in very carefully, pay attention to order of operations, and this sign of 22.5 to see that they match up. All right, this one is very similar. It's all yours. Pay attention to those things that you're supposed to look out for. Pause the video. Here we go. The half angle is in quadrant 1, 67.5. Make sure that you're using the half angle's placement for the quadrant, not where the whole angle is. Last time we didn't have to worry about that because both of them were in quadrant 1. Most of the time you do. Here's an example. When we double this 67.5, 135 moves to quadrant 2, but that's not what we're trying to find. We want to find this one, so we have to pay attention quadrant 1. Cosine in quadrant 1 is positive, so that positive's coming down all the way. Again, another thing that's important is finding the whole angle and the cosine of that. Cosine in the second quadrant is radical 2 over 2, but it's negative, and then we're plugging stuff in. Okay, since this one's cosine, our formula is 1 plus on the inside, but 1 plus a negative is minus again. So, once again, I replaced this 1 so that we could simplify this inside first. 2 over 2 minus radical 2 over 2 we can smush to 2 minus the square root of 2 over 2. Then we're multiplying straight across. See how that 2 minus radical 2 is just from distributing that 1. And then 2 times 2 is 4. But that 4 comes out nicely to the square root of 2. All right, last type of problems picks up the double angles that we haven't covered and puts all together the double angles, the half angles, and making sure we get the right quadrant for just solving for sine or cosine based on what we're given. Okay, so they look right now similar to the first problems we did, but we're going to find all of these things. Okay, so what I'm going to do here is call this B, C, D, and E. Now, the reason A isn't there is because A is finding what's missing. For sine 2 theta, your formula, if you recall, says 2 times sine times cosine. We're given sine here, but we weren't given cosine. So the first thing you have to do is find that, okay? Because otherwise you won't be able to find the double angle, okay? So what you want to do here is solve for that first, remembering what quadrant you're in, and then you can simplify all those others. I'm hoping that B and C you find pretty easy, provided that you get the right sign, S-I-G-N sign for part A. So let's do that together for this first one. So this right here is quadrant 2. I'm going to draw a triangle, and I need the sign, which is opposite over hypotenuse, to be 8 over 17. So 8 over 17, that looks good because we're in quadrant 2. Everything's positive for those ones. And then we have to go find this missing side. Well, 17 squared is 289 minus 8 squared is 64. That leaves us with 225. The square root of that is 15. Going to the left here, we need a negative. So this is actually Pythagorean triple, an 8, 15, 17, but it's not necessarily one I expect you to recognize. Just be careful with your Pythagorean theorem and you won't have any issues there. Okay, simplify a radical if you need to and pay attention to the sign. We decided that 15 needs to be negative, so our cosine would be a negative 15 over 17. From there, you should be able to do B, C, D, and E. Pause the video, and I'll go through each of those when you're done. All right, we already talked about A, so I'm going to skip to B. That just takes 2 times the sine times the cosine. You want to look if you can cross-reduce here at all, but in this case you can't, which means you won't have to simplify that fraction when you're done, so that's good news. Over here, what I did, because remember there's 3 different formulas for cosine, what you want to do is pick the one that has what you're given. So we were given sine, which means I want to use the formula that has sine in it, and that's 1 minus the 2 sine squared. I don't want to use anything that has cosine in it, just in case I messed up part A. I don't want to mess up part C as well because of that. All right, so what I'll do in the case of this is kind of look out for myself, and here's how I mean that. I know that the 17 squared is going to be 289, so anytime I see a 1, I'm going to call it 289 over 289. Then here, we just have to subtract the 2 times 64, so 289 minus that gives us the 161 over 289. Again, there's nothing to cross-reduce here, so that means that fraction you won't reduce anyway. Then we've got our half angles, okay? We've practiced a couple of these, but remember we have to figure out the sign that goes out in front. That's based on where the half angle lands. So our whole angle was in quadrant 2. If you split both of these in half, we're between 45 and 90, which is quadrant 1. Okay, with quadrant 1, they're both positive. So positive, positive, you want to jot that down so you don't forget about it in the end. And then we can go to work on simplifying. Okay, we found our cosine being negative 15 over 17. Subtracting a negative makes positive. And again, we want to call that 1 17 over 17 to combine like terms. The 1/2 comes down, and then it's 32 over 17. Now, what I did here was just take this 32 divided by 2 and called it 16. So then I've got the square root of 16 over the square root of 17, which comes out nicely on the top there. If you were to rationalize this by multiplying by 17 over 17 first, chances are you wouldn't know that the 16, that perfect square, went in evenly to that large number. Okay, so look out for perfect squares as you're doing those half angles. Okay, it'll save you a little bit of time. Similarly on E, the sign just switches at the bottom. So here, in the middle, we've got a minus, and then we can do the same process, 17 over 17 instead of 1. This time we're subtracting, so that's 2 over 17. Once again, we can go ahead and simplify here and reduce that. If you don't reduce as you go, again, you have radicals that will need broken down. So try to look out for simplifying before you rationalize. Then we've got 1 over 17. The square root of 1 is 1. See how I simplified that? If you would have done the times by 17 over 17 first, no big deal in this case because that perfect square was 1. That's it for that one. And then I've got one more here for you. Okay, so again, find the missing piece, so find cosine, and then you can go ahead and solve this one. All right, let's check it out here. We started out in quadrant 3, which means our missing side was negative. The square root of 5 does not break down, so that's good news for us. Remember 9 minus 4 to get that 5. Okay, then we can substitute that in for the next part. 2 times sine times cosine. Okay, here we've got a negative times a negative, which ends up being positive. And then there's no cross-canceling here, so we don't have to worry about reducing. For cosine, we want to use the one that has sine in it, so that's 1 minus the 2 sine squared again. So here, call this 9 over 9, and then it's 9 over 9 minus 8 over 9 to get 1/9 for that one. Hopefully those ones aren't too bad. Again, it's just with those half angles that sometimes we struggle. Remember, find sines first. So our whole angle was in quadrant 3. We take half of that and we land in quadrant 2. That means our sine has to be positive and our cosine has to be negative. Okay, so write those down first and drag them along for the ride. A lot of times, even with this positive, I'll put a plus in front. That way I know that I did check those signs. Okay, from there, we just sub in our formula. We're subtracting a negative again, so it becomes plus. And here, we'll call this 3 over 3 and smush them. do this inside first. From there, we have 1/2 in front, and then 3 plus that radical 5 over 3. And then we can multiply straight across. With this 2 terms, remember we have to distribute through. That 1 keeps all those things the same, but then we're left with a 6 on the bottom. So here's the problem. We've got the square root of 3 plus the square root of 5 over the square root of 6. And we can't leave a radical in the denominator. Okay, so what we need to do is multiply by something to get to a perfect square. Remember, always look at that bottom number and ask yourself, would it break down? Because if it would break down, that means you don't want to multiply by itself. But in the case of the square root of 6, that doesn't break down. There's no perfect square that goes into it evenly, which means it's okay for us to multiply by itself, just 6 over 6 underneath that radical. Okay, so then we distribute that through. 6 times 3 is 18, and this 6 times radical 5, we just smush it. Okay, pay attention to those radical symbols. 3 is under 1, 6 is under 1, which means it's okay to combine them. But this 5 is under 2, which means you just got to put that 6 in the front there. Then we've got 6 times 6 is 36, and the square root of that is 6. Now, we do have to work hard for these ones because they get so messy and we have to worry about simplifying and rationalizing. But the nice thing is, once we work hard for sine, we don't have to work hard for cosine. We have to make sure that the sign on the outside is what it's supposed to be based on the quadrant it's in. 2 in this case, but then all we have to do is take that sign in the middle and switch it. So I'm okay with you not showing work for those second ones as long as they have this sum or difference of something with a radical in it, because then they're really going to end up looking mostly the same. Okay. Hopefully you found this helpful. If you do have any other questions, be sure to email me, let me know.